So, from deep learning, let's go to natural language processing. Um, so, in natural language processing, we have three model tasks, three basic tasks, so to speak. So, the first basic task is so-called classification, sentence or text classification, and in this case, uh, we have a sentence or a document, and we want to classify that into different labels. For example, if we have a sentence like "I hate this movie," then maybe you want to classify this as a sentence that utters negative sentiment. And this is important, especially like for several industry players such as Google, Amazon, or Facebook, also because they want to declassify the huge amounts of data that they have. For example, also could be relevant for Facebook, who want to classify um, their commentaries and their conversations into whether they are racist, sexist, or other things, and then maybe they want to eliminate that. The other model task that we have is called sequence tagging. There, instead of giving one label to a big unit, such as a document or a sentence, we want to label each unit in the sequence. So we would want to label each word in the whole in the whole document or in the whole sentence. Uh, and a model problem within this class is to like do part of speech tagging. Like part of speech tagging, part of speeches are word classes. So word classes are something like verb, determiners, noun, adjective, adverb, and we would then want to label each element in the sequence that we have with exactly one label. Um, and the third model class that we have is the so-called sequence-to-sequence model, or sec-to-sec. This is the most difficult problem type. In this case, we want to transform one sequence, like the English sentence, into another sequence, and this could be a German sentence. And in this case, we would call this machine translation. So the problem would be to transform "I hate this movie" into, for example, "diesen Film, ich hasse ihn." And you will also notice that this not only does it have a different number of output units, so you have 1, 2, 3, 4, 5, 6 units here, while in English you only have 1, 2, 3, 4. Uh, so this is one difference to sequence tagging. So we transform 4 units into 6 units, where here we transformed, so to speak, 4 units into 4 units. And the other thing is that the ordering is may not be preserved at all. So here you have a a totally different order um, than in the English input. So these are the three model types that we have in natural language processing. And if we want to connect deep learning with natural language processing, then what we could look at is what kind of fundamental questions do we have in deep learning, and how do these fundamental questions relate to our fundamental problems that we have in natural language processing. So the two fundamental questions that we have is which neural network do we use? So we have already seen two such neural networks, namely the perceptron and the multi-layer perceptron. There are others that we will come to learn in this lecture. One of them is the recurrent neural network. Particular cases are LSTMs and GRUs, a convolutional neural network, and an encoder-decoder model. And the second fundamental question that we have is, how do we represent our input? And the answer to that question will be embeddings. And we will learn about these embeddings in later lectures, and also in these lectures in the next couple of slides. But before we talk about them, let's map our three fundamental problem types in NLP, namely sentence or text classification, sequence tagging, and sec-to-sec models, to our neural network architectures. And what we could typically use is, for classification, we could use a perceptron or a multi-layer perceptron or a convolutional neural network. For sequence tagging, we would use a recurrent neural network. And for and for sequence-to-sequence models, we would use an encoder-decoder network, which consists of two recurrent neural networks or extensions of recurrent neural networks, such as transformer models. Good, but let's now talk about the input representation. What are our input representations? So they could be characters, they could be words, they could be sentences, or they could be whole documents. And so this could be our input. How shall we represent our input? A neural network always takes a vector, so like a sequence of real numbers as input, right? Doesn't take symbols as inputs, or it doesn't take discrete symbols, but it takes like vectors as inputs. So what should these vectors represent? So we want them to represent at least two things. Typically, the meaning of the units. Like this is called semantics. So what do these units mean? And also, we want to incorporate these representations, grammar, morphology, or syntax. So like this is the form or the structure of the data. And our goal would be, if we have a representation of the input of two input objects, then if these objects are similar, they should have similar representations. And what is the most classical situation? The most classical situation is that we are dealing with words, and that we represent the meaning of these words. And how do we do that? So the most one of the first neural network architectures, and one of the most revolutionary ones in the context of deep learning, was the so-called word-to-vec model, introduced by Thomas Mikolov around 2013, 2014. And this is the visualization of the model. So we will come to talk about this model in much more detail in lectures. In lectures 4, 5, and 6. And yeah, so here are some details, like we use one-hot vectors,